Hi.
Hi, welcome to this Open Security Summit in April 2021. Michael Hidalgo is going to present some really cool stuff that we did on a project, on a real-world challenge. And it's a great example of actually the security teams adding value to projects, not just from a security point of view, but also, for example, to satisfy some very specific, in our case, customer requirements was to prove that there was no outbound traffic from the environment that we were setting up. So, Michael, over to you.
All right, thank you, Dennis, and thank you everybody for joining us. Just starting with a disclaimer, I am based in Costa Rica, so Spanish speaker. Hopefully, you can understand everything what I said. If not, you can use the chat questions to ask the questions, right? So this topic is very exciting, specifically, with the pandemic situation of COVID-19. We have seen a lot of, organizations moving to the cloud and choosing multiple of the, public cloud providers. And there are a lot of challenges and risks associated to that move, specifically when you haven't taken design and architecture into consideration when moving to the cloud. So the idea of this talk is to just give a walkthrough about, how to use VPC Flow logs, what are they at the end of the day, and how, you as an organization, how you can actually benefit from that. So to start a little bit about myself, I am a software engineer and application security based in Costa Rica. I led the OWASP chapter from 2012 to 2020. Still try to be involved as much as I can. And I've been involved in the operations, security operations during the last few years as well. And I am a very passionate developer and cybersecurity researcher. I try to do a lot of research on my free time. And those are my links. I try to be active in LinkedIn and Twitter and write some articles. So before I start, this is a book that actually Dennis recommended back in 2012. It's called Trillions, and this book is interesting because it was created when the containers and Docker was starting in 2012 or getting some traction. And basically it says that there is a viewpoint that generally is called technological determinism, that essentially says that each technological breakthrough inexorably leads to the next one. Once we have the light bulbs, we will inevitably stumble by bacon tubes. When we see what they can do, we will rapidly be led by transistors and then integrated circuits and microprocessors. This process goes, the argument is essentially automatic, which each domino piece inevitably knocking down the next one. So when I try to apply this concept to what we have seen with the cloud, I mean, definitely this is true, right? I mean, the evolution that the cloud has had and continue to have is going to cause a major revolution around the world. So I just wanted to share that with you guys.
But Michael, this is also the worldly maps evolution, right? From genesis to commodity, right? Is the whole.
Yeah.
The thing that I think is very powerful when we talk about this kind of workflow is that it's very hard to predict the future when something is on the product stage. I predict a winner, but it's very easy to understand what will happen when we have a winner. So, for example, we don't know which light bulb will be successful, whether it's model A, B, or C, but you know that as soon as one of them is successful, a whole number of industries will emerge. And I think it's interesting to think about this, that even from a security point of view, we can say that we know that once X happens, and when X becomes a commodity, for example, a whole bunch of other things will emerge, right?
Yeah, pretty much, yeah, exactly. You're totally right. So for the agenda, basically, I just wanted to cover some of the AWS threats that are increasing and evolving. I think it's a good starting point to see, the cloud provides some level of security in this shared responsibility model, but still there are some specific threats that we can find in any cloud provider. We're going to talk a little bit about AWS flow logs and do some demos. Hopefully the demo doesn't break, and some conclusions, right? So security risk on AWS. As I was investigating this topic a few weeks ago, there is a very, very interesting research from Palo Alto Fox Unit 42 about, some of the studies that they have been doing around the challenges in the AWS, right? Specifically, they said that because of the pandemic situation of COVID-19 and teleworking, the number of incidents targeting the cloud is increasing, and that's somehow expected, right? Because as I said before, not every single organization was ready to get into the cloud, and because of the teleworking and things like that, they had to move without actually having predefined architecture, I would say. According to this report, some of the industries such as retail, manufacturing, and government, the number of incidents has increased significantly, up to 402% to 30% and to 100% as well. This same report actually says that the key for securing the cloud indeed is automation, right? Specifically because the business is evolving, more teams working together. The only way to maintain security in the cloud is through automation. The question is, basically the viewpoint here is that we need to prepare and be aligned with that automation and thinking that in security from the very, very beginning, which is important. This is very interesting article from that reading as well is very recent. Specifically, the highlighted square says that the rush to accommodate remote work through cloud migration solved several on-prem network shortcomings, but it's also exposed organizations to new faults in cloud environments, right? So it's like a security misconfigurations probably is one of those that we will see. And the idea is what I'm gonna try to explain is why VPC logs and monitoring at the end of the day will help us to deal with these kind of issues. As I mentioned, lack of security automation, that's one of the key items that everybody is highlighting. Specifically has number of incidents, overwhelming the cybersecurity team, right? I mean, if they were on-prem dealing with some amount of incidents, eventually at moving at the cloud, they have probably some overhead or a significant number of incidents to deal with. It is not, I mean, I really don't like to generalize, but it's kind of a trend.
Sorry, just double check. I think I lost your screen. Is that just me, or is everybody?
I think that might just be you, Dennis. I've still got it.
Okay, then it's me. All right, sorry.
Thank you. No, thank you for the heads up, Dennis. So an active monitoring in the cloud infrastructure is key to detect incidents very early in the cybersecurity phishing. I think, and you see this trend as well, most of the technologies allow you some way to monitor, to collect data, to collect logs. And this needs to be active and, pretty much 24/7 and centralized, which is more important. So what this report actually highlights, I wanted to put that into context, is most of those security misconfigurations are related to identity and access management security flows. As you can see in the image taken from Palo Alto research, an attacker or a researcher or a developer take advantage of a security misconfiguration in a policy, basically. And after that, they can either have access to sensitive information stored in private buckets, plain credentials if they are stored in plain, and even secrets or intellectual property such as a secure code or repositories and everything like that. So it's basically one of the avenues that threat actors are actually compromising the organization by taking advantage of security misconfigurations. Another threat that Palo Alto highlights is the evolving cryptojacking, right? So cryptojacking or mining cryptocurrencies in this kind of environment is frequent. According to that research, roughly 23% of the global organizations that have cloud infrastructure have been, have had any of those issues in particularly. Effectively, the attacker tried to bypass or to take advantage of a security misconfiguration. Eventually, they are able to evade security controls such as firewalls, VPCs, security groups, and then they use, according to the report, they are using Monero, either in the public and private pooling for doing this cryptocurrency mining. And what is more important, and that's why I wanted to join the dots here, is that this activity usually is not being detected by the organization. Why? Because this activity is involved or is basically hidden within the network overhead during the day-to-day operations. I mean, they use HTTPS, for example. So it's very, very hard to actually start detecting this activity if you are not actively monitoring and having a clear visualization of your current traffic. That's why flow logs are essential to detect suspicious network activities within a cloud environment. Well, the data breaches are a concern, not only in on-prem environments, but also in the cloud as well. So, basically organizations, I believe, from my point of view, data breaches is one of the major concerns for organizations. They have spent a lot of resources even, or they, at least from the risk management point of view, they understand that data breaches is probably one of the highest risks for them. However, not all the organizations have either the resources, either technical or economical to protect all the information and prevent that from a data breach. That's a sad reality, but that's what has been happening. Unlike on-prem environments, data breaches in the cloud have a significant impact for the company, such as penalties or fines, and probably the worst, which is the loss of trust, loss of customer trust when there is a data breach, right? And I really like the compliance or reference guides. One of those is MITRE ATT&CK. I've been talking about MITRE ATT&CK for a long time, actually since 2017, I believe, when I get involved into the concept. Because MITRE ATT&CK, for those of you that are not familiar with the concept, is basically a knowledge base that describes how a threat actor behaves in terms of tactics, techniques, and procedures, how it operates. So these guys basically have a very large knowledge base of attacks targeting cloud environments. In this case, they have one for AWS in particularly. And you can see from the screenshot, hopefully you can see it, but there are different stages. You can see, for example, that attackers are exploiting public facing applications. They are actually trying to elevate privileges by exploiting valid accounts. In terms of credential access, they are brute forcing. That's a reality, right? I mean, you go to AWS, you rise or you start up a VM and you leave, let's say, port 22 open, right? In probably half an hour, 1 hour, you get a lot of attacks trying to break into SSH, for example. Also, the use of EC2 credentials is important, and obviously the impact for the organization. So let me just stop here to show you something really quickly. Hopefully you can still see my screen. So if you go to MITRE ATT&CK, for example, they, in terms of the cloud, can somebody confirm that you can see my screen still?
Yes, I can see it.
Yep. So this is the AWS matrix, right? As you can see here, multiple clouds have different patterns as well. And you can identify from here what are the metrics applying to a specific technology, and you can actually get those details. For example, credentials of brute forcing, you can go here and actually get a grasp of what is this technique in particularly, what kind of environment it targets. Some examples of APTs or advanced persistent threat groups that are using this kind of thing. And you are lucky, you can find here references with good PDFs and studies of investigations from security companies that explain this in a deeper way. So this is very important. I mean, keeping this landscape into perspective is important at the time of securing our infrastructure. The other model that I like, and I've been studying for the last couple of months, is this one from Cloud Security Alliance. It's called the Cloud Control Matrix version 4, right? So these guys have interesting domains. And as you can see here, I'll just scroll down in this matrix. They have a lot of content or security checks in terms of auditing and logging, right? So you have data security, for example. Let me scroll down a little bit. And at the very bottom, you have also governance, risk, and management and compliance. You have also human resources categorizations or domains, I would say. And here, right? So you have identity and access management. And at the very bottom, you have logging and monitoring. So as you can see, they already are taking into consideration that you need to have this kind of thing within your deployments. it's good to take a look at this matrix. Maybe you can create a checklist. Maybe you can create a maturity model to see where you are at the moment and where you can be. And then something important is the cross mapping. I think there is an interesting movement at the moment to do cross mappings of the technology, meaning that, for example, if you are, you are under a heavily regulated environment such as PCI DSS or HIPAA, these guys actually provide some sort of mapping, specifically for the previous version, which is the version 3, but also with ISO. So effectively, I mean, if you need to present your results in ISO, you can do the cross mapping and present a report, a maturity model based on that. I believe, these security checklists are very important for security, and this is what we are getting, right? Why we need logging and monitoring in the cloud, which is essential. Let me go back to the presentation. Okay, so the question is, what are AWS VPC flow logs or flow logs itself? So, and a flow log basically allow us to capture information about the IP traffic, either inbound or outbound, from the different network interfaces within a VPC. A VPC is a virtual private cloud. In this case, at the end of the day, it's like a firewall or ACL, keep it simple. And AWS provides two delivery mechanisms, meaning by delivery mechanisms, I mean, where do you store that data? I mean, the data that you're collecting, where is it stored? You can either deliver that to CloudWatch, and you can actually also deliver that to an S3 bucket. Depending on the culture of your organization, if you really want to centralize all those logs into a CM that allows you correlation, maybe you really want to go with the S3 bucket because you have retention logs, retention policies on top of the S3, and then using Lambda functions or using any technology, you can move the data out of the bucket to your CM and have this information centralized. Or you can actually have that in CloudWatch and create some interesting queries. Since flow logs are collected out of the path of the network traffic, something important is that does not affect the network throughput or latency, right? One might think that the fact that I am collecting so much information is gonna degrade the network performance or latency, but according to Amazon, that does not happen, right? And the creation and deletion of flows does not have any impact in the network performance. This is really good, right? What are, from my point of view,
Michael, just a quick one to clarify on that one. So what's the difference between the flow logs and raw network traffic, like the stuff that we get from,
the pickups, for example, or
pickups and Wireshark, yeah.
I guess is the level of granularity. In this, I will show you the schema later on, but basically VPC flow logs provides you information about this traffic where you can see connections ongoing and outgoing, ports and things like that. I would say is more reduced, is lightweight than a pickup, a full pickup. But for the interest of an investigation, when something has happened, it provides all the information. I mean, eventually which instance, EC2 instance is compromised, which ports are being used for the communication. Pretty much all the information except, the content itself or potential payload, that information is not available into the flow logs. Still, allows you to have visibility of the connectivity and probably allow you to perform enhancements. And that's why, there are some use cases for VPC logs or for flow logs. Security is probably one interesting, but if you are a network engineer, you can use this kind of information to diagnose, for example, overlay restrictive security groups. Let's say you're troubleshooting, you really want to enhance or to raise the security posture of the organization by restricting security groups. So one option is that, for example, you can monitor the traffic from the security groups and start enhancing, like applying more rules and things like that. You can monitor the traffic reaching to your instance, and you can determine the direction of the traffic, the routings and everything like that. So what information, sorry, are you gonna have something?
No, I thought that was cool.
Okay, good. So what kind of assets we can monitor with flow log? So you can apply flow logging at 3 levels. At the VPC level, when you apply that to the VPC level, both the network and the subnets are going to be monitored. You can actually restrict that to a specific subnet, or you can apply the VPC, flow logs to the network level. The use case that I have been working on more is at the VPC level, and it provides a really good granularity. And this can be effectively automated. Essentially, a flow log is a log event that consists of fields describing a traffic flow. So, this is an example that is taken from Amazon. As you can see here, you have a VPC here, you have an instance, and the traffic of this instance is to send that to an S3 bucket, but you have a subnet, and in this subnet you have 2 different instances, and those flow logs are collected and are actually sent to CloudWatch. So you can combine things. For example, in the test or in the demo that we're going to show you, we are sending that data to both places, to CloudWatch and to S3 bucket. So you can see the capabilities it provides. It's not a good idea to duplicate that, but for the sake of the demo and to show you that can be done, I have decided to do it this way, right? So, flow logs for network interfaces, you can collect.
But actually, sorry, could just go back to that diagram for a second, right?
Sure.
One of the things that is also really good with this is that, those S3 buckets, you can drop them to like long-term storage. So they are, they are something that, you can then, start putting in Glacier or something for past information, right? Or if you want to do photo analysis, right? I think it's quite a cool pattern, right? It also depends,
exactly.
in a way, it depends on how you want to understand the traffic, right? And what you want to see the flows.
Yeah, exactly. That's a really good point. Either you really want to store that for long term, let's say you have regulatory compliance, or you need to comply with a regulation that requires you to store the data for 1 year or so, you can either keep that data within the policies or the retention policies of the S3, or you can actually, just move that from a different place, like a centralized them. From what I have seen, CloudWatch is a really nice way to do quick analysis of that data. If you really want to do further analysis, probably you have the capability to move that to a CM solution. It probably might be better, but I guess, for very quick analysis, CloudWatch is like the right way to go. It allows you to have a good visibility. So if you are gonna monitor network interfaces traffic, you can do that at the elastic load balancing level, sorry, to the elastic cache to NAT gateway. So that's good. Essentially, these are all the fields that are available when you collect a flow log, basically. So you have things like the account ID, you have the interface ID, you have the source IP, the destination IP, the source port, the destination port, metrics about the packet size. And this is very important, right? Because if you really want, for example, to find anomalies, you can start implementing like statistics and try to identify potential peaks in the size of the packages. So you can see, give me in this month the top transactions where we have, a peak in the packet size or the sizing bytes of a given package and things like that. So there is a lot of opportunity to detect anomalies. You can actually apply a model for the destination and source IPs, and you can see, for example, you are seeing traffic coming from Russia that you haven't seen that in the last 30 days. If you apply machine learning modules to this data, eventually you can start identifying anomalies. Doesn't really mean that this is bad. It really means that something is abnormal according to the average, according to the statistics that you are going to apply. So as you can see, there are too many flow fields. You have action. This is, what is the action of that traffic log, if it was accepted or if that was blocked, depending on the policies applying at the VPC or the security groups. The status, the TCP flags, the region is very, very comprehensive. I mean, eventually you don't need all this data. The problem is if you select all those fields, the size of the logs is going to grow significantly. So you need to make like an informed decision of what information is useful for further analysis. If you ask me, I would select everything. The problem with that is obviously the size of the logs is going to grow. And it really depends on your retention policies and if you have the capability and the pricing, or basically the money to pay for that. But as you can see, it provides a lot of information. It is not perfect. I mean, it has some known limitations. For example, they are not available for the classic EC2 platform that I'm not sure if everybody is still using this concept nowadays. But for example, one of the limitations that this has is that it does not capture all the TCP traffic. For example, you cannot see information from DHCP. So eventually, you really want to capture DHCP traffic, you need to use a different approach for that. Other limitations of the VPC is that once you create the VPC flow, you cannot modify it. You need to delete it and create that over again. I really don't understand why that's the case. I mean, why it's not possible to edit an existing VPC flow. But if you really want to change something on top of that, you need to delete it and create that again. Creating a new one is not a big deal essentially, but still, you know, it's worth to take that into consideration. So how do we create this one? So the documentation from Amazon is pretty clear. Actually, you go here and follow this guide, and you can set that up. It's very easy. Essentially, you just need an IAM policy, right? The policy allows you to create logs, to put logs, to describe logs, and then you also need to create a trust relationship, right? So pretty much you follow the guide and create that to allow to put the VPC flows. You really want to put them into S3. Well, it's a bit different, but same. I mean, you follow the documentation and you need to create like the S3 bucket and give the respective permissions to that. So you can create logs and delete logs delivery. And then you apply a bucket policy that essentially allows you to put objects on top of that. That's pretty much, right? So let's do, I think I've been talking a lot. Let's do a quick demo. Before going that, I'm not sure if somebody yet has any question in the chat. Feel free to ask that at any time, please. Okay. So as Linus was describing, earlier this year we had an interesting case. I tried to reproduce that in a lower environment. So let's assume for this case that we have a very secure application. This is our architecture, right? So essentially you can see that the user needs to hit a very sensitive website, a transactional website that processes thousands of billions of dollars per month, right? We put this guy into a high availability schema, meaning that there is a load balancer, and meaning that the traffic is balanced between two instances. This is hosted in a VPC with some security groups. And by default, you know, we have filtered port 22 to some specific administration tasks. Port 80 shouldn't be open, but this is open at the moment, and 443 is also open. So effectively, the only way a user can interact with the application is through HTTPS, right? Let's assume we have HTTPS. The site doesn't have HTTPS just yet, but just for the sake of the demo. And on top of the VPC flow log, what we did is we enabled two flow logs that deliver those logs to CloudWatch, and the other one that deliver the content to S3, right? So let's see that in practice. Let me see. So to walk you through, here I created a brand new Amazon account. As you can see here, we have a load balancer. This is the load balancer that distributes the loads across the two instances from the previous diagram. If I go to the actual dashboard, there are three instances running at the moment. I explicitly put them node A, node B, so it's easier to follow the example that we are actually working with load balancing scenarios. And there is also an Elasticsearch instance up and running there because I wanted to send those logs to Elastic. Unfortunately, I didn't have too much time to put that in practice, but we will see what's going on here. So as you can see, those instances are within a security group, right? And there are some ports that have been designed for this application. Port 80 is open. Port 22 and port 80 are filtered for specific purposes for accessing the actual VM. And basically, we already have the CloudWatch. So let me show you how does this work, right? So let's say if you go back here to Amazon, basically you need to go to VPC, right? I have created a VPC when this thing loads. 1 second. So go here. So when you navigate to a VPC, this is a very slow, I apologize. So on top of this, I just have a single VPC, right? So you click on this. Still loading. You click on the VPC ID, and there is a tab called Flow Logs, right? So at the moment, as you can see here, hopefully you can see it. I have defined 2 flow logs, one that goes to S3, and the other one that sends the data to CloudWatch. Effectively, it's the same data. You can create a flow. For example, let's go here and create a brand new. You need to specify a name. For example, I can say this is test, flow. You can filter out. For example, if you really to reduce the clutter of the logs, you can either select all the traffic that has been accepted or all the traffic that is rejected. I personally have choose all the traffic, both accepted and rejected, because it will help me out to analyze and to understand the behavior. Maximum aggregation interval by default is 10 minutes. It means like AWS collects the data 10 minutes and then delivers that pretty much in real time. You can choose 10 minutes or 1 minute, and then you need to specify where do you want to deliver these logs, right? You really want to send them to CloudWatch or to S3. If you select CloudWatch, you need to select a previous created group that you create in CloudWatch. I will show you that in a minute. And then you need to select the IAM role. The IAM role is the one that we created before with the documentation. So this will allow us to actually put the log into CloudWatch. Now let's go to CloudWatch. For example, if I go here, I think I had the tab open. Just bear with me. CloudWatch. Right. So in CloudWatch, basically, the first thing you need to do to get data here when it loads is that you need to create a group to receive the logs coming from the VPC. So please bear with me. This is very, very slow. So as you can see here, I beforehand created a log group, right? So you go here and you create this. Loading. So this is the one that I created. So this can be reused by multiple VPCs. And the good thing about this is that you can create dashboards, right, with the data. So I have created a dashboard. It's called VPC Dashboard. And you can see, so you can change the interval. For example, I am displaying data during the last 3 hours or 1 hour. It might take a bit to load. I don't know why it's so slow for me this morning. But what I did is I have created some visualizations or some specific widgets, let's call it. So in this specific one, what you can see, I'm just putting all the timestamp. As you can see, is they are a bit delayed, probably for 1 hour. You can actually switch this to 1 hour, so you get less data. So the first visualization is actually like a table. In the table, you can see the actual event. So you can see all the information from the flow. In this case, let me open this guy. So you can see all the fields in here, right? And you can create functions or apply statistics functions to this data. As you can see here, you can see an IP address, a source IP, the destination port. In this case, I tried to illustrate or create a visualization that allows me to understand the amount of package transfer by IP address. So in this case, this is probably the most active IP at the moment. My IP should be here at some point, is this one, because I have been, that's my public IP, because I have been interacting with the EC2 instance. So you can see that there is a lot of traffic being generated by this one. Eventually, we want to investigate that, why this IP address, as you can see here, is generating so many traffics. It could be that it's the same one. We will need to double check this one based on the public IP, or at least start investigating who is this guy. But as you can see from the first grasp or the first visualization is that you can create this kind of thing. This other visualization allows you to, or what I try to do is to display the amount of traffic happening via UDP. I can see that again, this another IP, the one in orange, is generating a lot of traffic in UDP. This one basically allows me to see the different ports. You know, in this case, we can see that this IP, the 232, is being talking on port 80. Difference. This is important if we want to detect or to understand, for example, scanning happening. You can aggregate this by IP and see that there are too many, port scans coming from different IP to multiple ports. So this is important to take this visualization. This is another one. So you can see here, it might seems like there has been a port scan here. You can see multiple source ports, destination ports, and you can scroll this down as well. So you can create this kind of visualizations to get a really good understanding of the data. I have found that at this time, probably the functions in here are a bit limited. For example, if you are used to work with the Splunk or Elastic, probably you can have more like advanced graphs. Still, I guess, I think you can create something interesting. So let's suppose this is a scenario, right? I really want to do an investigation. We have suspicions that our instances have been compromised. And there's some activity from Sao Paulo, Brazil, and also from China and Russia that are talking to my website. So I really want to start an investigation. So one easy way to do that is you click add widget here, for example. And depending on the kind of visualization you really want to create, you can create a line, a stack area, a number, a bar. But for the sake of the demo, I really want to focus on logs. So when I select this table per se, right, I should be able to write a query that allows me to understand the traffic. So what we are gonna do here, we need to select the specific group or logs where data is getting into. This is the flow logs. And for doing this scenario, right, well, what the security team investigated is that according to a views IPDB, there is some specific bad activity from these IPs, bad reputation from these IPs happening. So you click on this guy, for example, you will get a report of why this IP has been considered suspicious or bad or has bad reputation. I hope it opens. Give me just 1 second. Okay, is it loading? So this IP is in China. Is very bad reputation, has been reported over 72,000 times, and is pretty much abusive for multiple, authentications and brute forcing things. So we in our scenario, we are concerned that we have presence of these IPs in our instances. So we really want to write a quick query that allows us to detect if that is happening. So give me just 1 second to open up the playbook. Okay, so in order to do that, you need to go back to the CloudWatch where we were creating the visualization. You select the groups of logs, right? So you select this one, and then you have to create a query. I already have created a query that allows me to have this visibility. So let me show you really quick. So basically, I am creating a table, a visualization. Can you guys see this? Or, I mean, is it easier to see? Dennis, can you see the screen?
Yeah, we can see it.
Okay, good. So in this case, I'm creating a query that basically says, hey, from the VPC Flow logs, I really want to get the timestamp, the source IP address, and the destination address and the destination port. Targeting one of those IPs that are bad known, right? you can increase, for example, the last 3 hours or so, and then you need to run, you run this query, right? As I mentioned, I don't know why this instance for me is very, very slow, but effectively in a very few seconds, you can actually see all the activity targeting. Actually, you can see some activity happening on that IP. For example, we can see that this instance, the 85 is targeting this IP, the 100.09, which is this one, on port 80 and port 443, right? So we can actually see this one, the 85, targeting the 248. We can actually increase the time range for the sake of the investigation, and then you can run the query once again. So please bear with me as we create the query. So basically, again, what I'm trying to do is investigate the logs in a very simple and easy way, which is once the security team tells me, hey, look, we need to investigate if we have presence of this, use these indicators compromise. They are well known to use this kind of, let's say these are command and control web servers, just for the sake of the demo. And you really want to understand that you have a very large deployment, and you really want to know how many instances are effectively compromised. I mean, that have a beacon that is talking to a command and control. So in this very easy query, you can actually look through that because you have all the space of instances and traffic being captured by the VPCs, and you can actually see that, right? So once again, you can see here the traffic coming up, specifically on multiple ports. So you can see that something installed on this instance in particularly is trying to talk to these IPs that are in the list, suspicious IPs on different ports, right? On port 8081, 443, 8088, and so on and so forth. You can see that the source IP is different. One is the 90 and the other one is the 85. If I go back, for example, to my very small deployment, I mean, here it's easier to see because I just have 2 instances, but I guess you get the point, right? You go to EC2, right? And let's pick up any of the VMs. Yeah. I apologize for the delay. And let's pick up this one, the node A. Node A has a private IP of .90, right? So effectively, I can pinpoint this machine and start the investigation. I know something actually is happening from here. I can actually look at the data in detail and start an investigation. Either like enumerating the assets or things like that. But you get the point, right? That with the this kind of activity very easily. And please note that I am not sending these logs to any correlation engine or any other technology that allow me to do sophistication queries and lookups and fits from the CTI or cyber threat intel. I'm just doing a very basic analysis. But with this analysis, I can start an investigation. I can start and go deeper, as you can see here from this event. And the good thing about that, you select what you need, right? And you create the kind of visualizations that you see. Something important is when we start working on this specifically, I see a lot of opportunities so you can enhance the security groups and the different firewall rules that you have within your infrastructure, because you actually start understanding the traffic. And this is important if you are working on a highly regulated environment. If you need to deploy something in somebody else's cloud. Why? Because same as happens with software. For example, if you really want to deploy an application into a customer on-prem, probably the customer is going to ask you, hey, Michael, tell me what is the bill of materials, right? What are the components, libraries, versions that your software are using? Same here. If you are going to do a deployment like this, probably if you are going to deploy this in a heavily regulated environment, the customer, if that person is in a compliance, a specific group, I would say, it's going to tell you, hey, tell me what kind of connections does this application do? and sometimes you really don't know, right? I mean, you deploy stuff and you really don't know what is happening. So with this kind of activity, you can actually start asking yourself, hey, that's very interesting. Why within my network, we are opening up connections to China if we don't have anything related to China, right? And I start like asking this kind of questions. So I see this as a bill of materials in security, meaning that we can enumerate connections. We are able to enumerate potential or find avenues to enhance the posture of the organization by reducing significantly ports that are not needed, or understand patterns. And eventually, you can apply, as I said before, the multiple patterns to this kind of thing, like a machine learning, like behavioral analytics on top of that, and get a different visualization. This is just obviously a trivial example, but you actually can see the power, right? That you have very, very good information here for do further analysis that can help you troubleshooting, that can help you in security, that can help you, from enhancing the posture of your organization by reducing the surface attack. So probably you need to shut down services, but you need to enumerate that kind of thing. And within this environment of DevSecOps, right, that people deploy stuff to production very, very quickly, we really need to start enumerating this kind of activities, this kind of network connectivities, understanding what they are, who are making them, and be able to expose and create the specific policies. For example, every time EC2 instance is created, let's create that with this profile. Let's add them to this specific security group where we have removed a lot of unnecessary ports and helps us, as an organization to enhance the security posture. That's how I see it when I start working on this. I guess, as I mentioned, the CloudWatch allowed me to have a really quick grasp of the data, a really good understanding. Obviously, you probably create more sophisticated queries for address specific questions or to get more visibility on top of that. But I guess this is one interesting scenario, right? That you can easily start mapping bad stuff happening within your network, right? I think that's pretty much. Let me go back to the presentation. But I'm not sure if that's a bit clear, or you guys have a specific question. But as you can see, there is a lot of avenue that you can use this information for. So final thoughts. Flow logs are very suitable option to have visibility on the network activity. Can be delivered to AWS CloudWatch and AWS and S3. I forgot to show you that, but in my scenario, I am sending those logs to an S3 bucket. So probably I need to log in again, but logs are there. I mean, are delivered to that S3 bucket. When delivering those to S3, those logs can be integrated or sent to a centralized CM solution if you have that in place. Monitoring is a priority, specifically as the cloud adoption continues to evolve. Flow logs are relatively simple to set up and implement. CloudWatch provides an easy and fast mechanism to fast analysis. To do deeper analysis, you might consider like moving that to a SIEM solution. From my point of view, that's not necessarily the case. But if you really want to integrate that or have more context, like a correlating data, probably you really want to send this data to a different place. Make sure that flow logs are set up with log retention, and that this log retention is adjusted to your compliance requirements, right? Depending on in the industry you operate with. And lastly, flow logs can help to diagnose and enhance the security posture of the organization by having a better view of the network traffic, right? So I think that's what I have for today. I hope it was helpful to understand at least the kind of monitoring level that you can have from the organization, why these logs are important, and why you need to consider like having those as a top priority within your organization.
Cool. No, great presentation, man. Any
you.
final questions? Yeah.
I hope you understand.
All All right, so I think you can stop the recording.